Hello, this is Tunç Türker. I am the team leader of IT Rover team. Me and my friends, we are all the students of Istanbul Technical University. In history of Turkey, Istanbul Technical University was the first to introduce lots of novelties and unique achievements. Now, we want to add a new one. We want to be the first team joining URC from Turkey.
As IT Rover team, we started to work in August 2016. First thing we did was organizing our team with 5 sub-teams: mechanical, electrical, software, science, and public relations and finance. With this team structure, now we have 30 people working hard to realize our first generation Rover.
As the mechanical team, we follow the path, which consists review, design, analysis, and optimization. In the review step, we focused on necessities. In the design step, we did 3D design of the rover. In the analysis step, we did dynamical analysis to find optimum dimension and finite element analysis to get information about stresses. In the optimization step, we did topological optimization for weight reduction. In September, we chose a unique design with rocker system mixed with double wishbone. However, we had production issues of this system. Then we turned to backup plan 6 independent double wishbone system, which is the most reliable, simple, and easy to produce. We chose T-slot aluminum in the main chassis, and we used aluminum 7070 pipe with voltage cutting for the legs. Rims were made with CNC lathe and milling machine, which provides precise production.
In our motion transfer system, to distribute load over a wide surface, we chose low pressure sand wheels. Also, we designed our custom-made rims and the other motion transfer parts to keep our motor inside the rims so that we can protect them from damages.
Robot arm must be able to perform tests quickly and stably to be successful in competition. We created one prototype robot arm and we designed a new robot arm. Robot arm has 6 degrees of freedom. In addition, DC motor and linear actuator are used as actuator. While designing the robot arm, the inverse kinematic analysis was done in MATLAB. Also writing GUI in MATLAB to determine optimum dimension of robot arm.
This is our gripper prototype. We have minimized the number of parts to keep it simple. The design allows us to grab both spherical and cylindrical objects like screwdriver using only one motor.
We have designed and developed custom smart controllers for actuators and sensors. Actuators are driven with closed-loop control system for current consumption and encoder positioning.
All subcontrollers and base station can communicate with each other over Ethernet network. Thanks to our modular network design, new controllers can be easily added and upgraded. 2 high-power access points link rover and base station via TCP/IP. We used high-gain directional antenna on a tracker at base station and high-gain omnidirectional antenna at rover to increase link budget.
UHF LoRa transceivers are used as a backup system for long-distance non-line of sight transmissions. As a power source, we choose lithium-ion energy cells with temperature control to maximize capacity and provide long run times.
As a software development team, our duties are to prepare a practical user interface, to develop control algorithms for the robotic arm and the rover, and also to navigate the rover autonomously. This year, we have prepared a well-planned development process which is based on simulations and tests. We are developing our autonomous navigation algorithm using robotic operating system. We have developed simulations to test our software and used our internal navigation system to achieve the desired drive.
We have developed a modular user interface and a built-in simulation. Furthermore, user interface creates a visual environment in case of a wheel loss. Also, the physics integrated simulation is used for training and debugging applications. We can simulate robotic arm's 3D position in our interface. We will control our robotic arm using a joystick via inverse kinematics and iterative forward kinematics.
In the science sub-team, we will use hydrochloric acid and reflectance spectrometer to determine soil hospitability and microscope to observe microorganisms in the soil sample. The drill system uses a selector to separate the samples. After measuring soil characteristics, it can obtain the sample from 15 cm deep by only 2 motors.
To identify presence of liquid water, we will use data gathered from pressure and temperature sensors and interpret this data in water phase diagram. Soil temperature and humidity sensors will be used for selecting proper samples to store. Also, we measure pH to find out biological activity.